Hey, what up? Welcome back to another quick Flutter tutorial. In this one, I'm going to be showing you how to code a game like Snake using Flutter. And then more importantly, once we lose, we're going to show this little alert dialog to collect the user's name so that we can store it in our backend using Firebase. And then we can read back, say like the top 5 or top 10 high scores. Then finally at the end, I'll show you how to host this game as a web app so that all of you can play and it's not just an offline game. So I'll link the game below as a pinned comment, so play the game, and it should be interesting to see in like a few weeks time what the high scores are going to look like. Now just before we start, I want to give a shout out to the sponsor of this video, which is Rotato. I'm sure you have all seen in all of my intros, I love using Rotato to showcase my work, especially as an app developer. This is a must-have if you want to show your work in a professional manner. I'll link it below, so make sure to check them out. But without further ado, let's do this. So I've opened up a brand new Flutter project, and just to keep everyone on the same page, in my main function I'm running my app, which is bringing us to this home page, which is a stateful widget, and inside I've just got a blank scaffold. So this is the blank app that we have, and the first thing I always like to do is to split the screen up into different sections just so that I can lay out the UI easier. So what I mean is, let's create a column and let's have a bit of a plan for the UI. So at the top, I want to display some high scores. In the middle, let's have the grid for the actual Snake game. And on the bottom, let's have a play button that the user can press. So one thing I like to do is to use some expanded widgets to split the screen up in proportions. So for example, if I just give this a color, but let's change the middle one to green. Expanded widgets just fill the entire screen. So 3 of these is going to split the screen into these thirds. And one useful thing is this flex property. So if I say like flex equals to 3 and it's 1 by default, the middle one is going to be 3 times as big as the blue sections here. So for the game, we want to make it kind of like a nice arcade game. So I'm just going to get rid of these colors. This is just for us to see what the expanded grid was doing. So for this Snake game, it's kind of like an arcade game, right? So I'm going to get rid of these colors and have a bit of a dark theme. So maybe we'll just make the screen black. So let's start with the most important thing, which is the game grid. And then we can fill these out in just a second. So for the expanded grid of flex 3, I'm going to use a grid view builder, and I've actually made a separate tutorial covering grid views, so check that out if you need. But just to show you here, I'm going to use a sliver grid delegate with a fixed cross axis count. And so the cross axis count, this is just saying how many do you want in a row. So let's say, for example, I want 10. And let's create this grid. So each box that I'm going to return, let's just return a container. And just so that we can see it, let's give it a pink color. Now it's a grid of pink, so let's just put in a little padding so that we can see these squares. Cool. Now I don't think I specified an item count, so it just gave me an infinite list of boxes. So let's specify here an item count, let's say 100. Cool. So this is just a 10 by 10 square. And another thing is, just while we're playing the game, I don't want this to be scrollable, right? So just specify in the physics, never scrollable physics. And if you save that, cool, so we can't scroll this anymore. Sweet, and at this point, it's probably a good idea to put these numbers in variables so that we can just access them later on. So instead of just explicitly saying 110, let's come up to the top and let's just say the grid dimensions. And so I'm going to have row size, which is 10. So that's just how many in each row. And then the total number of squares, and that's 100. Okay, so it's going to be a good idea to put these in some variables so that if we change these values later on, it's not going to give us a headache. And also let's make these pixels a little bit more better to look at. Like for example, this padding is a bit too big, right? And we can actually put this decoration, and I think we can put this color inside the decoration. And most importantly, I just want to decorate this border radius. So right now it's such sharp corners, which I don't like. So let's make it a little bit curved on the corners. Cool, and the color, let's make it gray. And this gray could be a bit darker. Let's say like 900. Cool, so yeah, let's leave it at 900. And so this is just a blank pixel, right? So if I change this to a different color, then we can represent a pixel that has a snake on it. Okay, so I'm going to make that white. And a green pixel is going to represent the food. So it's just going to be a matter of changing the colors. So what I'm going to do here is I'm going to create a new file called blank pixel.dart. And this is just going to be a simple stateless widget, just called a blank pixel. And copy this guy and put him here. And we can just now return a blank pixel. So nothing changed. All I did is I just put all of the code into this file, so we can just change this one in the future if we need. Makes our homepage look a little clean here. Now at this point, let's try to create a snake and display it on our grid. So snake position. So for the snake position, I'm just going to use a list of integers, call it snake position. And I'm going to say like 0, 1, 2. So one useful thing actually, if I just show you real quick, this index, which is going through the total number of squares, the way it works is it starts from 0, 1, 2, 3, 4, 5, and it goes all the way through until the 99th or 100th square. Just to show you real quick, I think this is pretty helpful if I show you. So returning a blank pixel. Now just real quick, if I just return the index, like what this index is doing. Oh yeah, by the way, because our app is very dark, I'm actually going to change the theme here real quick and change the brightness to be dark, and this will invert all of our colors. So yep, this is the text widget, and I'm just displaying this index, and you can see that it's going through from 0, 1, 2, 3 all the way through to 99. So including the 0, this is 100 boxes, and each number I can use to represent as a coordinate, or specifically it's actually technically an ordinate, right? It's not a pair of numbers. But regardless, the snake position 0, 1, 2, what I'm saying is I want the snake to be at 0, 1, 2. Okay, so that's what this index tells us about. So let's just bring this back to this blank pixel. And one cool thing you can do is let's create a new file called snake pixel and import our material.dart file like usual. And for this one, I'm actually going to copy this blank pixel, but we're going to change this and say snake pixel. And instead of gray, let's return white. Okay, so snake pixel and blank pixel are the same except for the colors are different. So now I can come to my grid view and say, let's get this blank pixel that I'm returning, and I'm going to say if snakes position, which is a list, if this list contains the index that I'm currently looking at, then let's return the snake pixel. Else, return the blank pixel. So if I save this, we created our snake earlier here. So this is the 0, 1, 2, and so 0, 1, 2. So this grid view is just going through all of the item count. And so for each index, I'm just checking if I'm in the snake position, then return the snake pixel, return a white pixel. Otherwise, just return a blank gray pixel. So using this, we can actually do the same thing for the food. So I'm going to say food location or food position. The food is just one position at any time, so I don't need a list. I'm just going to create an integer and say food position. And let's just fix a particular number for now. Let's say like 55. Somewhere in the middle. So let's create another file called food pixel this time. And so just grab our earlier pixels, and I'm going to change this to food pixel. And the food, we're going to make this green. So now it's checking the snake position. Let's check as well. So else if food position is equal to the index, then we're going to return food pixel. And there it is. There's our food. Sweet. So far so good. Now let's create a play button here. So if the user clicks it, our snake starts to move. So that's down here. And so in the center, let's create a material button. And let's just say play. And this material button is going to need a color. Let's just say pink. And lastly, on pressed, we should specify what happens if I press this button. So I'm going to fill that out a bit later. Hey, so there's our play button. So if I click this button, let's start the game. So if I press this button, let's call a method called start game. So void start game. And the way I'm going to do this is I'm going to use a timer. So you're going to have to import this one here, the Dart asynchronous. And what this timer does is we can specify a duration. So I'm going to say 200 milliseconds. So every 200 milliseconds, what do you want to happen? So what I'm going to do is I'm going to set the state, and every 200 milliseconds, I want to change the snake position. Okay, I want to add 1 to each of them. Now, when you make this snake game, there's actually 2 approaches you can take when it comes to moving the snake around. Like the snake position currently has 0, 1, 2. And so the kind of naive initial thought that one might have is to just +1 to each number. So like +1, +1, +1, and this will move everything to the right. And that does work, but what will give us a lot less headaches later on in the code is to say, instead of just moving all of the pixels to the right by 1, just grab your tail and just plop it onto the head. Okay, and then if you keep doing that, it'll create this feeling of just movement. So that's what I'm going to do. So every 200 milliseconds, let's add a new head, remove the tail. Okay, so this way we don't have to get the code to do too many operations. You know, like later when the snake becomes so large, it's going to have to do so many calculations, like adding 1 to each of your pixels. And so this way, no matter how big the snake is, it'll cost the same amount of time and same amount of operations. So this is probably a good idea. So adding a new head, how do we do that? So snake, let's just assume for now everything is moving to the right, and I'm going to say snake position dot add the snake position, the last element. So right now it's 2, so that's the last one. So whatever the last one is, I'm going to add 1 more. And then let's remove at 0. So the 0th index, meaning it's the first one. Okay, let's see how this looks. Fingers crossed. If I press play, yay, everything's moving. So yeah, the tail is just plopping onto the head. And the game, Snake 1, by the way, is, you guys probably know if you've played it before, but Snake 1, you can't go through the walls. For this one, let's make it Snake 2 so that we can go through the walls and stuff. But yeah, we're going to have to adjust a lot of these different stuff, because right now it's just going off the end and we can't see it anymore. But hopefully you guys get the idea. And now it's actually, we're at this stage where we have to take into consideration with direction. Like right now, this is all assuming we're moving to the right. Let's now get some user input, and so the user can swipe around and change the direction of the snake. So to get the user input, the first one I'm going to add in is just the ability to swipe it around. So if I swipe down, the snake moves down. So this grid view builder, I'm going to wrap with a widget called a gesture detector, which detects a gesture. And usually we use this on tap gesture detector just for basic purposes, right? Like just when you tap on a particular widget. But there's actually a lot more options we can have a look at. So the one I'm going to do is, it's like on vertical drag update. And it will tell us about this details. So I can show you how this works, but if you didn't, I'll show you how you can sort of figure out how this works. Like it gives you these details. And so if we get the details and get the delta, and then you should be able to see this dx and dy. So let's look at the dy, because this is the vertical update, and it's going to be between positive or negative, so because it's a direction. So I just want to see, right, like if the delta y is positive, then print moving up. Okay, I don't know if this is really the case, I just want to check, right? So if I just show you, here, so you can see like I'm actually dragging down and it says move up, so I can see that this is actually saying move down, whereas if I flip this around, it should be moving up. So hopefully this corresponds to my movement here. So if I drag down, yep, it's moving down, and if I drag up, it moves up. So this way I can know what the user is doing. So that was for the vertical drag update. If we say for the horizontal drag update, it should be very similar. So give us some details. And let's copy this one. And this change to X, and this change to X. And let's figure out what the left and right is. Should be like that. So down, up. Looks like the right and left are swapped around. So this is moving right, that's moving left. So that's moving left, and that's moving right. Cool. So this is very important for us to know what the direction is of the snake when the user drags their finger around. Okay, so this printing is was just for me and for us to know what's going on with this code. So now that we know that this tells us that it moves down, I'm going to create an enum up here, which is basically, if I just show you snake direction. So what this enum does is we can basically set what the 4 possible directions are. So I'm just going to call it snake directions, and we can have up, down, left, and right. So why are we doing this? Well, we can say, let's actually bring it here and say snake direction is initially to the right. So I can say like variable current direction is snake direction right. Okay, so I'm going to store the direction in this current direction, and initially we'll just set it to be to the right. But when the user touches the screen, we can say current direction is down. Whoops. Snake direction down. This one is up, right, and left. Cool, so now we are keeping track of the current direction. So coming back to the movement, right? So going into the start game, we're starting this timer, and every 200 milliseconds, we're moving the snake. So currently this is assuming that we're moving to the right, just by plussing 1. So let's actually separate this out. I'm going to copy this. And let's separate this out into a new method called move snake. Okay, and at this point we're actually going to use a switch statement. So you can actually use an if statement, and like say current direction is equal to snake direction dot down, and like create a few of these ones so that you can just check down, up, left, right. You can use a bunch of if statements, but if you have like 4 situations, probably a good idea to use a switch and a case. And so what are we checking? We are checking the current direction, and we're going to think about the different cases. So when it's going to the right, let's do something. And let's copy this and say, okay, what about when we're moving to the left? What about when we're moving up? And what about when we're moving down? So we can put the block of code into here now. So, whoops, I lost what I had before. So what did we have? It was, if I'm moving to the right, it's add a head, remove tail. So we had snake position dot add snake position and the last guy, but +1. And also snake position, remove the very first one, the 0th index. So that's if we're moving to the right. Let's make sure to put this in here. And then if it's moving to the left, it will be the same thing, but we're going to subtract 1. So that's going to be moving everything to the left. And also, if we are going up is a little different, because if we're going up, we're not actually plussing or minusing 1. We're plussing, minusing an entire row. So if we're going to go up, that's actually subtracting the row size. And going down means we're adding a row size. Whoops. Okay, so let's see if this is actually working. Let's go play. Let's drag down. Yeah, and drag left. That's it. So now we can move this snake around properly. Now, one thing I want to make sure that you can't do is if I'm moving right, then I shouldn't be able to go left. Yeah, like in the actual snake game, you're not actually able to just move left and right. So that's an easy fix. We can say in the vertical drag update and the horizontal drag update, in each of these checks, we're saying, okay, we're going to move down. So we have to do an extra check and say, make sure the current direction is not up. Okay, so basically what I'm checking is, well, if I'm going up, then you can't go down. Okay, so you can't just go up and down, or left and right, left and right. So actually for any particular direction, you should only have 3 possible moves, right? Like if I'm moving towards the right, you can either go up, down, or just continue going right. Okay, you shouldn't be able to reverse yourself. So that's just what this is doing. So let's just add this little check to everyone. So if I'm moving down, then I'm not able to move up. So just make sure I'm not already going down. Make sure I'm not already going left. And make sure, as long as I'm not moving right, then you can set the direction to be left. So if I just save this and try again, you shouldn't be able to, so I can't go backwards. Okay, so I can just move like a normal snake. Cool, so far so good. Now just before we go to the eating the food, if you look at the snake game, I want this to come back on the same row, but just because it spills onto the next row, that's how the numbers work. So when I get to the end, I'm going to have to just adjust it a bit. So to do that, let's go to the moving snake, and when we go to the right, let's add a little check. So I'm going to check if snake is at the right wall, adjust, need to readjust. So if snake position dot last, so the very head of the snake, if that's 9, so snake position dot last tells us the column that we're currently in. So if you're not sure about what this percent sign does, it's called modulus, I'm pretty sure, but it tells us about the remainder. So because our row is from 0 to 9, meaning there's 10 in each row, if I find this number that's like 9, 19, 29, 39, 49, etc. So I'm just basically saying if the head of the snake, which is the last one in the list, if I'm at this particular column, which is the 9 column, then we want to readjust. We want to do this, but let's just subtract a row size. And otherwise, just do the normal thing. So let's see if this works. So hopefully when it goes to the end, it'll just pop up at the same column. Sweet, it doesn't spill over to the end. So I'm just checking if we're at the end, just subtract the row. So let's do the same thing for moving left. Now this one, we're going to check if your head is at 0, right? 0, 10, 20, 30, 40. Then we're going to minus, minus, plus. Cool, there it is. So left and right works. And finally, up and down. So up and down is a little bit of a different check, right? So with up and down, let's say if the snake position dot last is less than the row size, right? So I'm just checking if we're in any of these ones, because row size is 10, so less than 10 would be these first 10 here. So if that's the case, then we can say snake position dot add snake position dot last minus a row size, and then plus total number of squares. So right now, if I move down, it's just going to continue going down and moves off the screen. Okay. Same thing is as if I go up, it just continues to go up and goes off the screen. So I'm going to use this total number of squares to readjust the board, so it'll just keep looping through. So let's just see if this works real quick. This one without this. And I'm just going to copy this and do the same thing here. But I'm probably going to have to change. Yeah, plus, plus, minus. The last one. Plus row size is smaller than total number of squares. Oh, is greater than. So basically if I'm going down and the last one is greater than the total number of squares, then we're going to just keep moving down, but we're going to subtract the total number of squares so that we just reappear here. And it should work for the plus as well, going upwards. Cool, so this is our snake game. Now we're at the stage where we can actually eat this food now. Eating the food is pretty fun. So right now when we set the state, we're moving the snake. Keep the snake moving. And then now we have to check if snake is eating food. Now, what I'm going to do is I'm actually going to check this eating the food when we move this snake. So right now in this switch statement, if you go to the very bottom of the switch statement, let's say if snake position dot last is at the same place as the food, then let's eat the food. And then otherwise, let's remove a tail. So if you actually look at what we've been doing here, in each of these directions, we're removing the tail and just plopping it onto the head, right? So we can actually simplify this code a bit because each direction has this remove tail portion. So let's just get rid of these duplicates and bring it down here. So I'm going to put it in this if else statement. So what this is doing is if I'm eating the food, then just eat it. Otherwise, I'm going to remove a tail. So if you actually see what this does, it's going to make it seem like we are growing. So you see how it became 4? So removing the tail kept simulating the feeling of movement, but if I'm eating a food, then let's just not remove the tail, okay, and get the snake to continue growing. And one thing I need to do, so if I just move down, let's make it into 5. You can see there's 5 in there now. So in the eat food, I need to move this to a different location. So if I ate the food, Then I'm going to do a while statement, and basically while the snake position contains the food position. So I'm just checking if the food location is in the same location as the snake, then we need a new location. So food position is equal to random dot next integer total number of squares. So this code will tell us, it'll just pick a random integer within the total number of squares. And this while statement is just making sure the food is not where the snake is. So let's just save this and let's see if the food goes to a new location. Yay! And if I eat it, then it just keeps popping up somewhere new. Cool, and the snake is growing in size, so we're making some good progress now. So the big important thing that we need to do now is to know when the snake is dead. And the snake is dead when you hit yourself, right? Like when the snake hits its own body. So let's do that now. So let's come down to the bottom of these methods and create a game over method. For this one, I'm going to make it a Boolean method, meaning if I call this, then it's going to return a true or false value. So let's think about when the game is over. So the game is over when the snake runs into itself. And this occurs when, so if the snake runs into itself, then that means in the list of the snake positions, there's going to be a duplicate number in there, right? So if all of the numbers in the snake position are different, then that's normal. So like this, 0, 1, 2, all of the numbers are different. But as soon as you run into yourself, then the latest addition would have already existed in the body, right? So this occurs when there is a duplicate number in, or duplicate position in the snake position list. So there's a lot of ways to check if there's a duplicate number in the list, but I'm going to do something, I guess, a little nice and fancy just to help with the space and time complexity. So what I'm going to do is I'm just going to create a new list of integers, and I'm going to call it body snake. And so basically I'm going to just give it the same list as the snake position, but we're going to get the sublist and just go from 0 to the very last one, subtracting 1. So this list is the body of the snake. No head. So why am I doing this? Well, now we can do a quick check and say, well, in the body of the snake, does it contain the last number added to this snake position? So remember, the latest number that's added is the head of the snake. So does the head of the snake also include the body of the snake? If this is the case, then let's return true because the game is over. And if none of that gets executed, then let's return false. So let me know if you don't really understand this bit of code, but I'm just checking to see if there is a duplicate position in the snake list. So now I can come to the top and say, once we start the game, every 200 milliseconds, let's keep the snake moving and also check if the game is over. So let's say if game over. So if this is true, then first of all, let's cancel this timer. And I also want to display a message to the user. So let's show a dialog. Whoops. And we're going to return an alert dialog. And just to keep it simple, let's just say, let's return in the title, game over. Alright, let's check this. So first of all, I'm going to have to eat some food just to fatten the snake up so that it's easier to die. And hopefully when I run into myself, yeah, so I ran into my own body, so there's a duplicate number, so the game is over. And so we're going to cancel the timer and then show this dialog. So now we can actually show some more things in this message. Let's say in the content, we can say your score is, and then let's display the current score, which we are currently not keeping track of. So let's just say current score, and let's create this at the top here. So user score is going to be an integer, and it's going to be 0 at the beginning. And the score is going to increase every time we eat a food, right? So let's just increment there. And also, let's display the information at the top here. So this is where we had the scores. Let's actually change this to a row because I want to display the user current score. And then, so that's on the left hand side, and on the right hand side, I want to display the high scores. Maybe like top 5 or top 10. So let's say text user, oh wait, it was called current score. And current score is 0. Here, let's just say high scores, which we'll sort out later on. But it looks like it's all scrunched up to the left, so let's space this out evenly. Cool. And let's make this number a bit bigger. Cool, and let's wrap this in a column and actually just say current score. Cool, and it's up there. So let's make this into the middle. And let's see if this current score is going to get updated. So, hey, every time I eat a food, you can see the score is getting incremented. And hopefully if I just die, and then the current score is 5. Sweet. Now let's put in a button here to submit this score, and then we can later display it using Firebase. So first of all, I want to grab the user's name, and let's add a button there as well. So coming back to the alert dialog, let's wrap the content in a column, and let's introduce here a text field. And so in the input decoration, you can specify this hint text, which is a string, and just say enter name. And also, if you look in the actions, let's put in a material button. And if we press it, let's submit the score, which we haven't created the method for. And let's just say here, submit. And the color, let's make it pink. Okay, cool. And the submit score, let's just create the method here real quick. And we can do this stuff later on. Cool, so now that the game's over, the current score is this, and here we can enter a name. And later when we submit this button, then let's put all these values in a nice list in Firebase, and then we can display the high scores here. So just before we do that, let's just clean up the mechanic of the game and just make it so that the user can just play the game again, okay, instead of just stopping at the game over screen. So the first thing is I want to go to this alert dialog and change this barrier dismissible to be false. Also, one other thing is I don't want to make this play button clickable if the game is already in progress. So right now, if I click play and I click play again, it's going to go super fast because it's just calling the timer again and again and again. So for this, we're going to need a boolean just for game has started, which is false. And once you start the game, change this to true. And the reason why this is useful is because when you go to the play button at the very bottom, I can say something like game has started, then just show me a gray color. And if the game has started, then do nothing. So if the game has started, just show a gray color, and if the game has started, then do nothing when you click on it. Okay, otherwise we're going to do the normal stuff. So hopefully when I click play, you can see it turns gray, and so I can't click on this anymore until the user dies. And when we hit submit, we've got to dismiss this barrier, right? So let's go back to our alert dialog. And when you press the material button, so let's put in some more things here. So I want to submit the score, but I also want to pop the navigator. So once the game is over and we hit this submit button, we're going to pop the alert dialog, and let's also submit the score and start a new game. So this is just to reset the values back to the original. So for example, like this. So let's set the state, bring the snake back to its original position. We also had the food position, just bring it back to 55. Also the current direction, let's make it right at the beginning, and also game has started is back to false. So let's see if this works. Cool, so just type some name and submit it, and everything goes back to the beginning except for the current score. We should also say current score is back to 0. Cool, and then you can play this again. Sweet, so now that our game works in an offline way, let's turn our attention to hooking it up with Firebase so that once we die, it says game over, your score is 7. And I want to be able to type my name, and then I want to submit. And here where it says high scores, I want to have in Firebase the data of all of the high scores that are submitted. And let's just return, say, like the top 5 or top 10 in the list. Okay, so we can have a nice like multiplayer situation going on. So the first thing we're going to need to do is to go to your Firebase console. If you've never gone here before, then you're going to need to sign up with your Gmail. But let's click on a new project. I'm going to call it Snake Game. And let's hit continue. And I'm just going to select the default account, and let's create the project. Cool, so your new project is ready. So let's click continue. And what I'm going to do is to first connect it to our app. So we've got an iOS app, Android app, app and web app. Now for this one, I'm actually going to connect it up with the web app because I want to later host it using Firebase so that you guys can all access the game and play it through the browser. Okay, so at this step, you can choose which one you want to hook it up to, but I'm just going to say web for this one. And let's register this app. And later we'll do this Firebase hosting as well. So if you haven't done this, then you can go ahead and install this Firebase, but we can also use a script tag and say copy and paste these scripts to the bottom of your body tag, but before any Firebase services. So just grab this script and then go to your web index.html and then at the bottom of the body, just paste in this script. And if I just look at what we pasted in, it says import the functions you need from the SDKs. So currently we have the Firebase app, which we're going to need, the analytics, and if you want to add more libraries, let's go to this website because I want to add Firestore. Okay, so they actually updated these script thingies, so just import Firebase Firestore. So I'm just going to copy this and say get Firestore, and you actually don't need to write this anymore. You can just say whoops, Firebase Firestore. Okay, so just this thing here. So that should be all good. And so if I come back to here, let's say continue to console, and we should have been able to add the app. Cool, so there it is. You can see it's connected there. So now let's come back to our main.dart file, and we're going to need to add this bit of code here. So widgets Flutter binding, make sure it's initialized, and we also have to do change this to a future, and we're going to await Firebase and initialize the app. And actually we didn't even import any of these, so let's go to the pubspec.yaml, and then underneath the dependencies we're going to add in for the Firestore one. So this is the latest version as of today, so just save it. And so now we can import Firebase, and so we can say now Firebase Firestore initialize app. Cool. Okay, now I'm just going to run, so I was making this on an iOS simulator, but let's get rid of this, and I'm going to run it using the Chrome browser. Okay, let's run this, see how it looks. Okay, cool, and I'm just getting this error, which I commonly ran into when I was trying to do this. It says this options cannot be null. Firebase options cannot be null. So I dug into this and I found a solution. Have a look at what we added here. Grab everything inside this. Go to the options here and say Firebase options, and paste everything that we just had. Okay, so if I just rerun this, then we get no errors and our game is loading up on the browser. Sick. Now, one thing about web browsers, as you guys all know, the window has different sizes, right? As opposed to like a phone, like the width changes. So we're going to have to just sort of update our code so that it doesn't just stretch out like this. So there's a key thing that we can do. By the way, I also made a separate video about this particular topic, which is called responsive design. So check that out if you want to know a bit more about how to deal with different screen sizes, which is really important when working with Flutter. But I can show you real quick how we can go about this problem. So if you look at your homepage and we go to just the build method. So in the build method, we can just get the screen width and say double screen width is equal to media query. And here you can get the size, and we can get a lot of useful things here. So I'm just going to get the width. Okay, and for the column, I'm just going to wrap it in a sized box. And this sized box, I can control the width. And so what I'm going to do is, if the width is too large, then I'm going to restrict it. Okay, so for example, if the screen width is greater than, say, 400, then just leave it as 400. Otherwise, leave it as screen width. Okay, so what this is saying is, let's check the current screen width of the browser. If it's greater than 400 pixels, then restrict it to be 400. If it's not greater than 400 pixels, just take the screen width of the current device. So if I just show you, you can see here like the screen width is already bigger, so it doesn't affect the actual game. Okay, so this number, by the way, if I just show you, so I'm just looking at the screens of different iPhones. So you can look at different phones, right? And if you look at the width, it says the logical width, which is the pixels. So 390, 375, 428. So they're all around here, right? So I'm just going to get the biggest number. So like 428, right? So if it's like greater than 428, outside of that, it should be all good. So this number is an arbitrary number that I just chose to sort of fit most screen sizes. Okay, so now it's time to submit the score. So I'm actually going to need to have a controller. So I'm going to create here a name controller. And this name controller is going to be given to this text field. Okay, so that's where the user is going to type in their name. And so using this controller, we can get access to what that name is. And so once we hit submit, then we're going to submit the score. Now, when we submit the score here, if you go back to your database, if you go to the Firestore database, we should create a database real quick. So just create a database, and we can do just test mode for now. And we'll just leave the location as US Central. Cool, and in here, let's start a collection. And I'm just going to call this selection ID. Oh, sorry, the collection ID. I'm just going to call it HIGHSCORES. And let's collect two things about the HIGHSCORES. So name, let's just say just a test robot. And then the score itself. And this one can be a number. And let's just say 10. So this is just some dummy information. Okay, so let's try to create this in our code. So when you submit the score, so first let's get access to the collection. So what I'm going to do here is create a database, and it's Firebase firestore.instance, and then in the database we are looking for the collection. We called it high scores, and we can add. And the way you want to add the data in here is in the format of a map, kind of like this. So it's going to look like name is what we want first, and we're going to give it the name controller, but just the text from that controller. Oh shit. And then we have the score, and the score is going to be the current score. Let's see how this works. So I'm going to save this and let's play this damn game. So let's go. Okay, so I lost. Your score is 4. Enter your name, Mitch. Submit it. The game has restarted. And if I come back to my Firestore, you can see that the name and the score has been updated. Yeah, so using this, we can now collect all of the users that play the game into here. So that's how you add data to Firebase. And finally, now that we've added the data, we can now look at these high scores and let's return some of the high scores, okay, like top 5 or top 10. Okay, so how do we do this? Well, let's come to the top here and let's create some things here, okay? So the high score list. So first of all, I want to get the document IDs. So that's just these document IDs representing each person. So I'm going to say there's a list of strings. And I'm just going to call them high score doc IDs. And also we're going to create a feature called let's get doc IDs. So this feature, the reason why we're using something called a feature is because it takes time to load information from the database. So once we play the game and we're retrieving information, it's going to take a couple, seconds or milliseconds. So it's going to be a feature. And then, so in the initial state, when we first fire up the game, let's get the doc IDs, and we're going to create this method now. So future get doc ID, it's an asynchronous function. What I'm going to do is say await Firebase Firestore instance, and we know what collection we're after. It's the high scores, and we can actually order the information in terms of the score, and specifically I want it to be descending, right? So from highest to lowest. And then you can even limit it to 10. So just give me the top 10. Yeah, so once you have that, then you got to call this get. So we're going to get the documents, and then I'm going to then add this. Okay, so just to quickly sum up what we just did. So when we initialize the state, so in other words, when the game starts, we're going to call this getDocID method, which will take a little bit of time to execute. So we're just waiting for the collection of high scores. And specifically, I want to get the scores from descending order. And I just want the top 10. Okay, so get me that information. And once I've got it, let's go through each of the documents. And I'm just going to grab the reference.id, okay, and add it to the doc IDs. And so essentially what I'm doing is I'm just collecting the document IDs. So if I come back to the UI portion in the build method, so here is the high scores. So in the high scores, let's create a list view. Okay, and display in a list. So if I want to do that, then I'm going to use a future builder because it takes a bit of time to get the information. Okay, and in the builder, we are going to return a list view. And in the list view, let's just return the high score doc IDs and each of them for now. Okay, and we're going to specify how many to print out. Well, just however many document IDs we've got. And in the future builder, we're waiting for a future, which is the let's get doc IDs. Okay, so let's see if here it prints out our document IDs. And actually, I should expand this because list view needs a specified height. And sick, there it is. So you can see that document ID, that's these two information, right? So now in each of these, let's display the name and the score. Cool, we're making some good progress. And just to make our code nice and clean, I'm going to create a new file called HIGHSCORES. So for the high score tile, what I mean is I just want to have a tile saying the name and the score given a document ID. So just give this widget a document ID, and then from there, I want to be able to access these two bits of information. Okay, so we're going to need to require this document ID. Let's do something similar as what we did before, which is get the collection of high scores first. And then instead of returning a container, let's return a future builder, and specifically a document snapshot. So the future is going to be the high scores, and then you can get the document, right? So this high scores gets us here, and then we can now give it a particular document ID, right? So whatever the document ID that we're currently looking at, and then let's get that. In the builder, let's say let's just do a quick check. So we can say snapshot and the connection state. So remember how we said when we are accessing the data from our Firebase, it takes a bit of time to load the information, right? So just check the connection state, and we'll say if the connection state is done, then let's get this data. Okay, so I'm going to say map string, and dynamic is the snapshot.data as this one. Okay, so I'll just quickly explain what this is. If you're not sure what this is saying, map string dynamic, this is essentially the format in which this is. So it's like, okay, the first two has to be a string, and then the values can be dynamic. It could be a string or a number. Okay, but I essentially want to collect the data in this particular format. Okay, because then we can say return a row, and the first text widget is going to be data name. Or actually, let's display the score first. And then get the name. Okay, so the data, we can just insert whatever field that you're after. So I'm after score and I'm after name. Okay, so that's what's going on here. So that's if the connection state is done. If it's not done, just return text widget saying loading. Okay, let's see how this looks. So coming back to our home page, we are only displaying the document IDs, right? Like this. But now we can display the high score tile and we can give it our document ID. And hopefully if I save this, it looks like we have an error. So expected a value of string, but got one of type int. So that's going to be something here. All right, here we go. So the score, we talked about this earlier, could be dynamic. And we know the score is a number. So let's change it to a string. And there it is, 10 robot for Mitch. That's this, for Mitch, 10 robot. And we did limit it to 10, like top 10, but we've only got 2 in there. So it's only displaying those ones. But yay, we can now add data and then we can read the data. Okay, now let's make this a little nicer to look at and say, give a bit of width between them. Cool, and it's very much on the left hand side. I kind of want to spread this out, eh? Oh, here it is, it's expanded, that's why. So I'm just going to also add this expanded widget, and this should just split it into halves. Okay, yep, there we go. Cool, so what I'm going to do is I'm going to play the game, and I can see one error we got to fix up. It's checking this after every frame because we're building and setting the state a lot. So one useful thing I can do is here. So in the future builder, I'm just going to say has game has started. If it has, then return a blank container. And if it hasn't, then let's display the high scores. Okay, so we're displaying the high scores, but if I start playing, then don't display the high scores. And let's just do a quick check here. So if I play this game and I die, my score is 6. Enter your name. Let's just say John. Okay, so it looks like it's added on our Firebase, but not updated on our game. So when we create a new game, which we created here, so every time a new game is called, let's reload the data. Okay, so I'm just going to have to change this to a future because we're going to load some data here. Okay, let's say await doc ID, and also just make this a blank list, and then we'll get the doc IDs again. Cool, so there it is. Now what I want to check is if I die once. So high score is 4. Let's just say Pete, submit, and load it again. And there it is. Cool, and you can see it sorting it from top to bottom. Okay, good. So we made a lot of progress. We created the game and we also connected it to Firebase, and so the user can submit their high score. And we can now read the information back from Firebase to have like a top 10 high score list. So that's basically all done now. Ugh. Now what I'm going to do finally is to just host this game, and I'll link it in the description so that anyone who wants to play it can play it and see their name up here. So that's the last thing I'm going to do, which is to host it. So I'm going to be using this hosting. Okay, so I'm not going to go too in depth in the hosting stuff, but if you do want to check it out, you're going to need to install these Firebase tools, okay, which I've already done, and I can show you this process real quick right now. So I'm going to need to show you my terminal. So I'm just going to delete this. First thing I'm going to do is build the web version. And then go Firebase init. And here you can access all of the different Firebase functions, right? So I want to do hosting and use an existing project, which I have a lot of. And where did we call it? It was called Snake Game, this one. And so what do you want to use as your public directory? So this is where we just created it. Single page app. Nope. Nope. And then finally we can say Firebase deploy. And then it will bring back a web link. And so I'm going to put this link in the description so you guys can play it. And you should be able to play it on your phone. So I'm going to wait for this deploying to finish, and you can see here, this one here, the hosting URL, right? So if I just go to this, and it's our game and we can start playing. Cool. So like I said, I'm going to link this in the description, and I'm going to see people's high scores. So this should be a pretty fun thing to do. What's up, bro? Now I just want to make one little final touch up to the snake game, and that's to do with the input. So I want to have the keyboard accessible for the user to move the direction around. So right now we're using a gesture detector so that we can grab the vertical and horizontal drag update. So if I play this on my phone, then I can use my finger to drag around to control the direction, right? And if I'm on the computer, which I am right now, you can use your cursor, like your mouse, to drag things around. But for the people that are playing this game on the computer, I do want the ability to use the actual physical keyboard as opposed to having to drag around using your mouse. So that's just what I'm going to show you here. So this gesture detector will leave so that the user can drag it with their finger or their mouse if they like. But if you're on your computer, let's wrap, if you look at this scaffold, just underneath with the sized box, let's wrap it with something called a raw keyboard listener. And we're just going to have to fill out a couple things. So first of all, we just have to specify this focus node. And this autofocus, we just want to be true. So we just have to set this up for the keyboard. And most importantly, it's the on key. So the event, you can hover over this and see it's a raw key event. So that's when the user hits a button on the physical keyboard. So just to keep it simple, I'm just going to use some if statements. And we can say something like if the event, and we can check the key pressed, logical keyboard key. And first of all, let's check the arrow down. So if I click the arrow down on my physical keyboard, then what we need to change is the current direction to down, right? So I'm just going to copy this and let's just create a couple more. But we want to change this to arrow up. And we have left. And we have right. So I'm just going to save this and let's see. So if I play this now, of course I can drag using my finger or the cursor, but I can now use my physical keyboard. So right now I'm not touching the screen at all, I'm just pressing the buttons on my physical keyboard. So if the user is playing this on the desktop, then it's probably a good idea to include this as well as the ability to drag on the screen. Cool. Now, one thing I just remembered is, remember when we did the directions, you should only be able to move in 3 directions, right? Like if I'm moving right, I shouldn't be able to move left in reverse. So that's why it's a game over. So we're just going to do a quick check. So similar to what we did in the gesture detector, we're just going to check the current direction is not snake direction up. Okay, so we're just basically checking if as long as we're not going up, then we're allowed to go down. So we talked about this a bit earlier, so I'm just gonna put all these checks in. And this is essentially to make sure that we can't go in reverse, right? So if I'm going left, then I'm not able to go right. So let's just save this and try again. Cool, so right now I'm moving left and it's not letting me go right, because you shouldn't be able to in a snake game. Now I'm just gonna leave it at that for this one. We covered a lot, so I hope you learned quite a few things in this video. We created this snake game from scratch, and so that was a good project in and of itself. And then we sort of upgraded our skills and we connected it to Firebase, and we were able to add the high scores to the Firebase, right? And then now we can read back our data from the database and just display the top 10. At the end, we just hosted it easily using Firebase, and now anyone can play, including you guys. So play the game. Maybe you guys can find a bug here and there. So I'm going to, like I said, link this game below in the description so that you all can play it. And it will be interesting to see actually the list in about a week time, like what the high score list is going to look like. So play around with it, and hopefully you learned something, and hopefully you got a bit of inspiration as to like how easy it is in reality to, I mean, it's 2022, so you making something and publishing it to the world keeps getting easier and easier as time progresses. So hopefully it gave you a bit of inspiration. But other than that, that's it for this video, and I'll catch you guys in the next one. Peace.